Hey all, welcome to the shop. Today I'm just going to do a short video on how to evaluate a milling machine for wear. What I'm going to do here is basically pick up how much does this table move up and down as we travel. So I'm just going to set an indicator up on it as far as I can go this way and set 0. Now, the last time I did this, the table moves about 1/1000th of an inch over 6 inches. So really not bad. And some of that is how tight the parallel is. I always try to hinge it. So we're high in the center, which is very typical because this T-slot is the one that's the most used, so it gets pulled upwards. And hopefully you can see through my head. And we're going to pretend I didn't knock that rule on the ground, and I'm just going to crank. We're going to see how much that indicator moves. Keep going, and we are, that is a lot of movement. Let's see if that repeats. I don't think that's correct at all. Now that makes a lot more sense. I think I got it tight at the end of travel. We're about 1/1000th of an inch there. That makes sense. Now 4 or 5 thousandths across that difference, I would not buy the machine. At that point, what you have is a particularly bulky, clapped out, poor drill press because you don't have the Z you would get with a similarly sized drill press. And if anything breaks, it's going to be a lot more expensive than a drill press. So don't buy that machine. You're not going to be happy with it. Now what I'm going to do here is move the indicator around and just see how much. Well, actually, you know what? We're going to use DRO. Work smart, not hard. So let's see how much everything wiggles in the center of travel. Now pushing on it hard out at the end, the most I can get is about 1/1000th. Now kind of bang in the center of my travel, I've got almost 10 thousandths. Now that's a lot more wear. Now what is that? That is also partially because I picked up the backlash. Now I've got 8 thousandths of backlash on this knee, or on this screw. So I'm going to zero it again and just wiggle side to side. So we've got 1/1000ths. Now I just picked up the backlash again. We're going to push and see if I can get that about 8 thousandths one more time. Now I can't. So what does that tell me? That tells me either the gibs shifted in there because they're not adjusted correctly, or it's harder than you think to take all the backlash out of that. So I'm kind of thinking it's still a reasonably tight machine. You know, most of the time I can push the table around thousandths or two. It seems if the stars align and I lean on it just right, we can move it that 8 thousandths or even 20 thousandths. That's wild. I don't know how I'm doing that because it's, I can't do that consistently. That's really interesting. But, you know, that alone, that's really mostly from the wear in the nut and where I'm picking it up. I think that my Y-axis nut might actually just be a little bit loose. I can pop that off and deal with it, but I haven't been fighting the machine to make parts. I really only fight the vise. Now we can try that same thing with the x-axis. And we got 5 thousandths in the middle, leaning on it. Not bad at all. We also get more backlash when you're in the center of the screw. That's the most worn part of the screw. I highly doubt I have the original nuts on here. So those are probably less worn than the screw is. See, we're not getting much movement at all out on the end. Now I'm going to push from the other side of the table and see what happens. Yeah, we're not moving much at all. Now this lines up with typical wear on machines that I see, which is the X is always in better shape than the Y. Now why is that? Haha. In my opinion, that's typically because people do most of their work in a vise and they're mostly cutting towards the head. So whenever possible, I try to move the machine table coming this way because that pushes my cutter into the fixed jaw of the vise, and that's where you're the most rigid. So now, is this a new machine? No. Is it a worn out machine? Also no. It's a serviceable machine. Now the other things to look at with these are, is it missing all these plastic knobs? Because that's typically a sign of abuse. Now, I pulled this out of literally the back of a truck where it had been sitting for 20 years because the previous owner didn't need it. And I had to replace this guy because I broke it. Now, that was just me being careless and lazy, but I've also replaced this bearing housing that slides up and down for your back gears. That was unfortunately about a $400 repair with shipping because I overnighted it. So not cheap, but not terribly expensive. Another thing to bear in mind is, does your power downfeed work if you can test under power? These are very often broken because they can kind of be fussy to engage and disengage, especially if you play with them when the power feed's not engaged. That's something to bear in mind. This clutch is often misadjusted or broken in there and generally worn out. Really what goes bad on the J-heads, in my experience, is mostly to do with the power feed or people who use a VFD instead of their belt speeds. Now I have a VFD on here because I don't have three-phase power, but what I don't do is I never run the motor under 50 hertz for any length of time. If you're using an edge finder, that's okay because there's no load, but you will heat these up and let the magic smoke out very quickly. Also, the worm gears to tilt the head and do the nod, those are weak points. I don't really know how common it is on the M heads because most of these, well, and the round ram J heads, but most of these machines have been out of commercial service for 40 years or more. So I haven't busted it. It's a pretty beefy gear in there, but you kind of have to fight the urge of, hammering on that. Because what's frustrating to tram these you don't have with the later models is this will move almost 2 thousandths as you tighten the bolts or more. So you have to get a feel for leaving this side high when you're tramming it so it comes back down level once you tighten the bolts. Also look at how beat up the screw on the knee is when you're looking to buy a machine. That's common. People will, and I do this once in a while, is forget to unlock the gibs before they crank the knee, and that'll strip that nut out right quick. But mostly is it floppy and loose in the y-axis? Now usually, in most of the time, all I can do is move it about 10 thousandths. I think that was a freak outlier that I moved at 25. I have no idea how that happened, but it's just like, how tight is it at the extreme ends of travel? Like, I can still crank very smoothly out to the end because, again, this machine's worn very evenly, which is good. So, like, if the machine's worn evenly because everything's taken off evenly on the y-axis, it doesn't matter as much as if someone was just moving the table like this far in the center and everything's like toast. But if you have that wear spread out over this distance, as long as you know it's there and you know how to compensate for it, it doesn't matter as much because the table's not doing this up and down. You know, you kind of have like a steady slope. So if you're within 1 or 2 thousandths of parallelism over 6 inches, say, that's usually plenty for what I do. It's rare that I need to be tighter than that, and typically that's on pretty small parts that fit on the surface grinder anyway. Now, kind of out at the end of travel, I really can't move that knee at all, or the saddle. I can move it 1 thousandths. So what we're getting is it's worn. It is what it is. Machines wear out. Vises, these suck. If you can buy a Kurt Vise, do it. They're really worth the $800. I don't have the spare $800 right now. If I was throwing $800 at anything, it would be probably repairs, not a Vise. I'd really like to replace nuts and lead screws and just throw some bearings at this as a preventative measure so it doesn't break down later. Spindle bearings are usually good on this. They are a constant loss system, which is a mixed blessing. So constant loss being you have to put oil in here. This is really critical. This is for your power down feed. You need to put oil here. Actually, is this for the power down feed or spindle bearings? I can't remember which does which, but you need to have oil in these cups, and you need to put every 4 hours running the machine, oil it. So it's a mixed bag, the constant loss. The benefit is you get an extremely good bearing life if you do the maintenance. But if people don't do the maintenance, they get toasted quickly. And what I have learned, if you're buying a used machine, unless you've taken the spindle out, assume it has open bearings. And if you don't have oil dripping out regularly when you turn the machine off, and if there isn't a puddle on the vise, you don't have enough oil in it. Now, you should also check and just make sure there's a wick in this bigger oil cup. That will control it. I've seen people use pipe cleaners. Those work great. But it's just really keep these lubricated. Don't ask the power down feed to do more than it should. You can't power down feed on this machine more than like a 5/16 or 3/8 inch drill bit in mild steel without a pilot hole. With a pilot hole, a 1/4 inch pilot hole, I've done 5/8 inch drills, but it doesn't feel right. I didn't really buy my drill press. I bought the parts to fix my drill press that I was inherited / was given / it just showed up one day. Because I don't like pushing these. They're not really drill presses. You can put them into service as such, but they're not designed for it. If you ever replace the clock spring, you should have enough friction that the spindle just stops. You don't want it to become where it flies up on return or you'll break something. And basically, a spade's a spade. If it looks like a worn out piece of crap, it is a worn out piece of crap. If it looks like it's been well maintained and cared for, it's probably a good machine. Even for a lot of commercial operations like myself, our degrees of precision aren't necessarily what you would see in a CNC shop making parts. Primarily, I repair parts, and what I do is questionable at best when it comes to precision because a lot of the times I have no idea what size the part should be. So I'm making a really educated guess based on worn components and hoping it works. But if you break a lot of end mills, something to check. Is your spindle taper beat up? I don't have the pin to lock an R8 collet in, and I'm frankly glad for it because what can happen if that shears off is you have to take the whole machine apart to take the collet out. If you spin the collet, and what I've found with a little upward pressure with your fingers on each side of the collet, that provides enough friction to get the drawbar tight, or start to tighten before friction takes over. But if your collets start looking really chewed up or your tapers start to look really chewed up, Like, this is a clearly worn spindle taper. You can see it. I don't have a lot of run out on it, and that can be hard to check, like what we were doing on the Y, where it's not necessarily repeatable, because a lot of that is based on how much oil film do I have in the bearings and is the machine warmed up. So I started actually heating the shop, not for me, but because this would sound like a maraca when you turned it on under 50 degrees, because your bearing clearances aren't there. You'd have to warm it up at really low speeds, and I didn't like doing that. I kind of figured paying the extra $100 a month in electricity was probably cheaper than breaking something expensive, between downtime and everything else. So preventative maintenance is a good idea. Keep these in a semi-heated space. Like above 50, they don't seem to care. The motors really don't get happy when they're over about 110 degrees. And basically just look at the machine. They're like anything else. The paint's toast on this because it's 70 years old, never has been repainted. But one of my big red flags looking at it is if it looks like a completely brand new, perfectly painted machine, the ways are toast. Always. People do that to sell clapped out machines to someone who doesn't know what they're looking at. See if all the knobs match. If you've got like 8 different knobs on it, that's kind of something to be wary of. Especially this knob here gets a lot of wear because you're changing belts. I mean, I changed that out because it was seized, rusted solid, and I broke it. So, that happens, but look at it. If all of your knobs are in various states of wears, that's kind of a sign that someone's been banging around on it. Another thing to look for is like hammer marks here. That happens a lot because people get careless. Putting stuff in the vise. I like to crank it out to the right because I'm right-handed, so I swing in from this side. So if I miss, I just hit the vise. Don't hit the head. The heads are expensive. And don't use this as an anvil. If you've got dents and apprentice marks all over the vise, or all over the table and the vise, that's usually a sign the machine was abused, unless it was in a school, and that's just because kids don't know what they're doing. Those will get the maintenance. They're usually not worn at all. They just are hammered. And you can fill that. You could fill it with lead. You could fill it with epoxy. Those aren't the end of the world. It's just kind of use your eyes. Look at what you're seeing. Deep gouges in the ways are a red flag. That means there's no wipers. Ask the previous owner if they oiled or greased it. If it was greased, you're in for trouble. Those ways are toast. This machine was never greased, fortunately, but I always like to flush it with oil. When I put oil in, make sure it comes out clear. When you first lubricate a machine, it is probably going to come out black as night because it's very rare you're going to be buying a machine that's been used regularly. Hobby machines tend to rust out. They don't wear out. Even things like mine, I'll use this 10 or 12 hours a week, maybe 15. As worn as this is, it'll probably be retired when I'm retiring, and I'm 30. So those are good things to bear in mind. If you're doing small parts, wear doesn't matter as much. It really just doesn't. When you're using the whole table, it starts to matter. If you're just primarily drilling and boring, it also doesn't matter because you're not going to move the part. Now that I've sufficiently talked your ear off and gone on God knows how many tangents for 20 minutes, I hope this has been helpful in your machine purchasing. And good luck. I mean, there are deals to be had. And it doesn't just have to be a Bridgeport. All of this information applies to any milling machine. It's look for wear, look for movement. You don't necessarily have to bring an indicator. Like if it feels solid when you grab things and move it, that's a good sign. If it's a dramatic amount of difference cranking it from one end to the other where you are in travel, that's also a sign of wear. So like a lot of it's feel, and the feel you develop after you own a machine and run it. So it's buying your first machine is tough. You're probably going to buy a turd. Spade's a spade. Because you're going to buy on price, especially if you're a hobbyist. You're going to look at the $2,000 machine or the $10,000 machine. And you can definitely have some fun you're just not going to be getting the parallelism, perpendicularity, and locational precision. Like, as the lead screws wear, they don't wear evenly, and the table doesn't move with the dials. I have a DRO for that reason, and also because I'm lazy. I don't want to have to write down how many cranks I'm doing and then compensate for backlash and fight with it. That's a lot of work. So it really is just like, take your time, don't rush to buy a machine. They make new mills every day. And for a hobbyist, I would really look at one of the name brand benchtop mills that'll basically fit on this, because this machine's good for doing 250-pound parts very, very slowly. You don't really do much hobbyist work. Like 90% of my machine time happens in a vise, and 90% of what you can do in a 6-inch Bridgeport vise, you can also do in a 4 or 5-inch hobby vise. You just won't do it as fast. And the space and weight and just hurting yourself requirements of a commercial machine like this are so much higher than the 800-pound bench mills. Just consider your safety when you're buying a machine. Like, are you actually comfortable moving over a ton of cast iron that happens to be extremely top heavy? Um, it. I have been lucky in that I've never gotten hurt moving equipment, but you can absolutely get maimed or killed instantly if this goes over. So bear that in mind as well, especially if you're older. You can take these apart, but that's a lot of work too, and you still run into risk of taking a finger off if you drop something. Like this table and saddle, I think is 300 pounds. Maybe two. I'd have to look at the shipping breakdown. So it's just, look into the hobby grade mills if you don't actually need this, or one doesn't fall into your lap for cheap, because these are also way more expensive to fix. When you buy a commercial machine, prices are commercial parts prices, because it's like a $400 bearing housing is $100 on one of the hobby stuff, because it's just not as overbuilt. These are made to run for 100 hours a week for 30 years. So thanks again for watching, guys. I hope you enjoyed it, and I hope you have a lovely rest of your day.